Hi everyone, this is your math guru. In this video, I'm going to show you how to interpret the following trigonometric graphs. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. We have in the diagram below the graphs of f of x equals cos of the angle x plus p and g of x is equal q sine x as shown for the interval from negative 180 degrees less than or equal to x, and x is less or equal to 180 degrees. Determine the values of p and q. To start with, I'm going to start by labeling my graphs. I have my f of x equals cos of x plus p, and my g of x equals q equals g of x equals q sine x. Now we have to find the value of p and q. Starting with the value of p, a quick recap of my trig function graph equation will be if I have my y equals a sine of b multiplying x plus c plus d. My a is the vertical stretch or the amplitude. The value of b determines my horizontal stretch or the change in the period of the graph. My c is my horizontal shift, and my d is my vertical shift. Now going back to my equation, I have f of x equals the cos of x plus p. So what this means is I don't have a vertical shift, so therefore I don't have a d value here. My horizontal shift, which is c here, will be my p. And then my amplitude has been given as 1, so there's an invisible one here as shown. And then my period is 1. So because I'm only looking for the value of p, my p, if I relate that with the standard equation, that is my horizontal shift. For me to know by how many degree my graph has shifted, I'll go back to my standard cos graph, which is my y equals cos of x. And if I draw my standard cos graph, that is my graph starting from 1, the amplitude is 1, and then I have 8 as shown. So therefore, if the value of x, I have that as my angles and my y values, if the value of x is 0, then the value of y will be 1. But if I go back to my graph, you can see that for my crest here, there has been a shift of my crest to 45 degrees right. And if I have a shift of 45 degrees right, what it means is if I write my equation, the value of p, so I have therefore, because it has shifted to the right, my p will be negative 45 degrees. So if I rewrite my equation, it will be f of x will be equal to the cos of x minus 45 degrees. If it's a plus, what it means is my graph has shifted 45 degrees to the left. But because it shifted to the right, that will be minus 45 degrees. To determine the value of q, my q will be the graph of g of x equals q sine of x. If I go back to my standard equation, the q will be my amplitude, which is a in my standard equation. Note that this graph doesn't have a d value, which means there is no vertical shift. So therefore, to find q, all I need to do is to check what my maximum displacement from the origin is, or the maximum value of my crest or my throw or my depth. So therefore, if I go back to the diagram and I use my function, the g of x, the maximum displacement as shown will be, if I trace it back to my x values, that is 1, or if I'm looking at my maximum depth, that is going to be at -1. There's no. But before I go ahead and say that the value of q is +1, I need to be sure that my graph hasn't reflected about the x-axis, and that will be me going back to my standard sine graph of y equals to sine of x. If I draw the graph of y equals to sine of x, that's the amplitude of 1 to -1, my graph goes in this format such that you can see that my graph is increasing from 0 to the right. But if I go back to my graph from 0 degrees, you can see that my graph is decreasing. So what that means is my graph has been reflected about the x-axis. So therefore, the value of q will not be +1 but -1. So I have my q equals -1 because the equation of my graph will become g of x equals -1 sine of x, which is the same as negative sine of x. Thanks for watching. Bye.